Hi, this is Thomas. Welcome to Algebra 2. Today's topic is counting methods. We're going to begin by looking at the concept of paths. And we'll start with a scenario in which we are at point A and we want to get to point D. And in between are points B and C. Now, if the only route from A to D is through B and C, then there's only one path from A to D. Now, in another possibility, we have three routes to get from B to C and two routes to get from C to D. So in this case, the total number of possible paths, looking at the nodes or the points where we have options. At B, we have three options. At C, we have two options. Now notice from A to B, there's only one option. If there were more than one, then we would consider that number as well. At D, we're at the end, so there is no additional decision to make regarding number of paths once we've reached the end. So in this calculation, the number of paths is going to be the multiplication of 3 times 2, or 6. In this scenario, from A to D, we have 6 possible distinct paths to arrive at our destination. Now let's say from A to D we have another possibility. And along this path, we have the points E and F. And let's say that to get from A to E, we have 2 possibilities. And to get from E to F, we have 3 possibilities. And from F to D, we have 2 possibilities. At E, we have 3, and then at F, we have 2. So from A to D on this new path, we'll apply a similar concept. We're going to multiply to get the total number of paths available. In this case, notice that we have at A 2 options, at E 3 options, and at F 2 options. So our calculation is going to be 2 times 3 times 2, and for this bottom path, the total number of, or for this bottom route, the total number of paths, 2 times 3 times 2, is 12. Now to take into consideration the top option from A to D, the bottom option from A to D, we're going to add. We have a total number of 6 on the top, and a total number of 12 on the bottom. And notice from A to D on the top is completely separate from A to D on the bottom. And to arrive at the total number of paths given all scenarios, we're going to add 6 plus 12 to get 18. So notice that on the top route we've used multiplication to arrive at total paths. Same for the bottom route. And then we add those 2 results to arrive at the total paths possible in this scenario. Let's look at another example. This is going to be a license plate. And we can think about this license plate as a path. And on this path we have 3 letters and 3 numbers. So the 3 letters and 3 numbers would be given as information in a particular scenario. Think about the license plate as a path going from left to right. The scenario is that we are not allowed repetition. So we will describe the scenario as without repetition, meaning that as we select letters for the license plate, we can't use a letter more than once. When we select numbers, we can't use a number more than once. So let's think through the total options available to create our license plate. In the first spot, and I'm going to create dashes for each of my options. And just like we did on one path, we're going to multiply across to get the total number of options. In the alphabet, the total letters available are 26. And I'll multiply. Now when I get to the next node, the next decision, I can't use whatever letter I used first. Now I don't know what that letter is, but whatever the letter is, I can't use it again. And now I have 25 letters to choose from. And then I'll have 24 letters to choose from. Once I get to the numbers, I'll start with 0 to 9. I have 10 possibilities. Once I've used a digit without repetition means I can't use it again. Now I have 9 possibilities. And then I'll have used 2 digits and I'll have 8 remaining possibilities. And when I complete my multiplication, I end up with the total of 11,232,000 possible arrangements or possible paths for the license plate given the scenario of 3 letters and 3 digits without repetition. This is the end of the first video on counting methods. When we continue in video 2, we're going to learn about factorial notation and the counting method concepts of permutations and combinations.